Hey guys, welcome back to the channel. As promised, in today's video, we are going to talk about zero shot and few shot prompting, two of the most fundamental prompting techniques used with modern large language models. But before we dive into them, let's first understand where these ideas came from and why they became important in the first place. Before GPT-3, the standard approach in natural language processing was to first pre-train a large language model on a large amount of text data and then fine-tune it separately for every specific task. For example, if you wanted a sentiment classifier, you would take a pre-trained model and fine-tune it on sentiment analysis dataset. Similarly, for various different tasks such as translation or question answering. Even though this approach worked pretty well, it had some limitations. Firstly, it required a large labeled dataset, which was expensive and time consuming, and every new task often required additional learning. Everything changed in 2020 with the release of the paper Language Models Are Few Short Learners. The researchers showed that sufficiently large language models such as GPT-3 could perform many tasks without updating their weights. Instead, they could learn directly from the instructions and example provided in the prompt itself. One reason this idea was so interesting is that it resembles how humans often learn new tasks. If I want to teach someone a new concept, I usually don't provide thousands of labeled examples. Instead, I give a few instructions or demonstrations and they infer the pattern from those examples. Similarly, GPT-3 demonstrated that large language models could learn from context alone, a capability known as context learning. So in this case, as we could observe, we first gave our GPT a few examples of English to French translation, that is in English dog and what's its French translation, and similarly for cat. And the model was correctly able to identify the task and correctly predict the French word of the English word house. So the paper basically evaluated GPT-3 models ranging from 125 million to 175 billion parameters, and researchers observed that as models became larger, their ability to learn patterns directly from prompts improved significantly. As a result, GPT-3 was able to perform tasks such as translation, summarization, and many others without task-specific fine-tuning. This marked a major paradigm shift in NLP. Researchers started moving away from the idea that every task required fine tuning and began exploring prompt based learning instead. And from this idea emerged prompting settings such as zero shot prompting and few shot prompting. So let's understand the simplest of these techniques, that is zero shot prompting. In zero shot prompting, we necessarily don't provide any example of the task which we need the LLM to perform, and we only simply give the instruction it needs to perform the task. So basically, as you can see in the example, we haven't provided any example of what it needs to output in the sentiment, but just told the task which it need to provide, that is to classify the particular text into a sentiment of neutral, negative, or positive. These instruction-tuned models, example ChatGPT, are much better at zero shot than earlier models. Instruction-tuned models basically means models which are trained on instruction dataset rather than just raw dataset. Like in the dataset which they are trained on has examples of classify, instruct, summarize, or explain. These models perform much better at zero shot than earlier models. Even though this worked pretty well on simpler tasks, it struggled a lot with complex tasks, and it was also very sensitive to the prompt wording. As we know, LLMs are very sensitive to prompts, and even a small change in the prompt wording can differ the output significantly. So, to tackle this approach, we started giving a few examples in the prompt itself. This is known as few shot prompting. Few shot prompting basically means that along with the instruction, we provide a few examples of what the LLM actually needs to answer. For example, in this case, while we are teaching our LLM a new word and how to use it in a sentence, we also gave it an example first and then asked it to do it one itself. In this case, as we have provided only one example, it's also known as one-shot prompting. Few-shot prompting technically is when we provide two or more than two examples. So the question why few-shot prompting works pretty well is that it has a lot of examples, so it understands what the output actually looks like and it understands how it needs to output. It also gets in context learning as it's able to understand the context which is set by the examples. Thirdly, pattern. From the outputs it has seen in the example, it's able to understand the underlying structure and pattern and able to answer likewise. And prediction, so it's able to generate the next response seeing all the previous outputs it has seen and what range it could have an output in. For example, if for a sentiment analysis class, if we only give positive and negative answers, the model understands that for further tasks also it needs to answer only positively and negative. So here is a comparison of zero shot and few shot learning. So zero shot prompts are generally very short and they don't contain any particular examples and only have instructions, and they work very well for simple and familiar tasks. On the other hand, few short prompts have generally have longer prompts because they only also have a few examples along with the instruction, and they generally have a better accuracy on complex tasks. In the research papers, the key observation was that even though 0, 1 and few shot prompting all improved with the scale, few shot improved the most. Even though few shot works pretty well for a few cases, it also struggles for complex reasoning tasks. As we could see, here we have to perform a task that the sum of the odd numbers in the group, does it add up to even numbers or not. So without providing any example, it answered incorrectly. But even though we gave it a few examples of what it needs to answer and how it needs to do the working, it still struggled with giving the correct answer. So we understood that few-shot prompting, even though it can significantly improve the performance by providing examples directly in the prompt, it struggles for tasks that require deeper reasoning, which led naturally to the researchers to ask an important question, that is, what if we could encourage the model to reason through a problem step by step before producing an answer? This idea gave rise to one of the most important prompting techniques in modern world, that is chain of thought prompting. And that's exactly what we will be exploring in the next video. Thank you guys for watching this video. If you found this video helpful, make sure to like, comment and subscribe, and also let me know where I can improve. Thank you guys.